The direct link to estimating tips is at www.mycult.com/estimating. PHP. Electrical fundamentals share common ground globally, yet crucial distinctions exist between electrical codes and practices in the United Kingdom and the United States. These variations span voltage systems, measurement units, and wiring methods, demanding careful consideration for anyone working across these regions. Let's explore some key differences. Firstly, voltage systems. The UK predominantly employs a 230-volt single-phase electrical system. This means that most residential and commercial outlets deliver 230 volts alternating current. In contrast, the US commonly utilizes a 120/240 volt split-phase system. Here, a three-wire system provides both 120 volts for standard outlets and lighting, and 240 volts for larger appliances like ovens and dryers. This difference in voltage necessitates different equipment and wiring standards. Secondly, measurement units. The UK adheres to the metric system, employing units like meters, kilograms, and amperes. Conversely, the US primarily uses the English system, relying on feet, pounds, and amps. This discrepancy affects calculations, conduit sizing, and wire gauge selection. For instance, cable sizes are expressed in millimeters squared in the UK, while in the US, they are typically denoted by American wire gauge or AUG. Thirdly, wiring methods. While both regions use insulated conductors, the specific types and installation practices differ. The UK employs cable types like twin and earth, while the US relies on standards like non-metallic sheathed cable, or NMB, and electrical metallic tubing, or EMT. Branding and bonding practices also vary to meet local safety regulations. Estimating electrical projects requires a meticulous approach, encompassing material costs, labor expenses, and project overhead. To perform effective electrical estimating, consider the following tips. 1. Define the scope of work. Clearly outline all tasks involved, from installing outlets and fixtures to running conduit and wiring panels. Review blueprints, specifications, and any relevant documentation to avoid misunderstandings. 2. Create a detailed bill of materials. List every item needed, including wire, conduit, boxes, fittings, devices, and equipment. Obtain current pricing from suppliers to accurately reflect material costs. 3. Calculate labor hours. Estimate the time required for each task, considering factors like complexity, accessibility, and worker skill level. Consult labor estimating guides or historical data to refine your calculations. 4. Add project overhead. Account for indirect costs like permits, insurance, equipment rental, and job site supervision. Allocate these expenses proportionally across the project phases. 5. Factor in profit margin. Determine a reasonable profit margin based on market conditions, project risk, and company goals. Ensure the markup covers all expenses and generates a satisfactory return. 6. Use estimating software. Leverage specialized software to streamline the estimating process, automate calculations, and generate professional proposals. These tools often include material databases, labor rates, and customizable templates. 7. Verify estimate accuracy. Review the completed estimate for errors or omissions. Compare your figures with past projects or industry benchmarks to identify potential discrepancies. 8. Consider future costs. Anticipate potential price increases for materials or labor during the project duration. Incorporate escalation clauses or contingency allowances to mitigate financial risks. 9. Stay updated on codes and standards. Ensure your estimates comply with the latest electrical codes, regulations, and safety standards. Attend industry training and seminars to stay informed of changes. 10. Document all assumptions. Clearly state any assumptions made during the estimating process, such as site conditions, access restrictions, or material availability. This transparency helps avoid disputes and manage expectations. For a deeper dive, let's discuss voltage systems in more detail. In the UK, the standard single-phase voltage of 230 volts is derived from a three-phase 400 volts distribution system. Residential consumers receive one phase and a neutral, providing the 230 volts supply. This higher voltage reduces current flow for a given power level, potentially minimizing conductor sizes and losses. In the US, the 120/240 volt split-phase system is derived from a center tap transformer. The center tap serves as the neutral, providing 120 volts between each hot leg and the neutral. The voltage between the two hot legs is 240 volts. This arrangement offers flexibility for powering both small and larger appliances. Concerning measurement units, the metric system offers advantages in terms of simplicity and coherence. Conversions between units are straightforward, based on powers of 10. For example, 1 meter equals 100 centimeters, or 1000 millimeters. In contrast, the English system involves more complex conversion factors. 1 foot equals 12 inches, and 3 feet equal 1 yard. These variations can complicate calculations and increase the risk of errors. Regarding wiring methods, the UK twin and earth cable consists of two insulated conductors, one phase and one neutral, along with a bare earth conductor for grounding. The cable is flat and typically installed within walls or under floors. In the US, an NB cable contains two or more insulated conductors plus a bare ground wire, all encased in a non-metallic sheath. EMT is a rigid metal conduit used to protect conductors in exposed or concealed locations. Installation practices for grounding and bonding also vary. In the UK, the protective earth conductor, or PE, is connected to the main earthing terminal, providing a low impedance path for fault currents. Bonding conductors connect metal enclosures and equipment to the earthing system, ensuring equipotentiality. In the US, grounding and bonding practices are governed by the National Electrical Code, or NEC. The grounding electrode system typically consists of a ground rod, metal water pipe, or concrete encased electrode. Bonding jumpers connect metal parts to create a lower impedance path for fault currents. These differences in voltage systems, measurement units, and wiring methods highlight the importance of understanding local codes and practices when working on electrical projects in the UK and the US. Now let's explore electrical estimating further. Electrical estimating is the process of forecasting the costs associated with installing or repairing electrical systems. Accurate estimates are essential for project bidding, budgeting, and profitability. The estimator must consider all factors influencing project expenses, from materials and labor to permits and overhead. To create reliable estimates, electrical contractors and engineers rely on a variety of tools and techniques. These include software programs, material databases, labor estimating guides, and historical project data. The estimator must also possess a solid understanding of electrical codes, standards, and industry best practices. Material costs comprise a significant portion of any electrical estimate. These costs include wire, conduit, boxes, fittings, devices, and equipment. Obtaining accurate pricing from suppliers is crucial for creating realistic estimates. Factors affecting material costs include quantity, brand, quality, and availability. Estimators often maintain a database of current pricing for common materials to expedite the estimating process. Labor expenses represent another major component of electrical estimates. These expenses include wages, benefits, and payroll taxes for electricians and other workers. Estimating labor hours requires careful consideration of task complexity, accessibility, and worker skill level. Labor estimating guides provide average timeframes for various electrical tasks, but estimators must adjust these figures based on project-specific factors. Project overhead encompasses indirect costs that are not directly tied to specific materials or labor. These costs include permits, insurance, equipment rental, job site supervision, and administrative expenses. Overhead costs are typically allocated proportionally across the project phases. Profit margin is the percentage of revenue that remains after all expenses are paid. Electrical contractors add a profit margin to their estimates to ensure a satisfactory return on investment. The profit margin should reflect market conditions, project risk, and company goals. Estimating software can streamline the estimating process, automate calculations, and generate professional proposals. These tools often include material databases, labor rates, and customizable templates. Some software packages also integrate with accounting and project management systems. Verifying estimate accuracy is essential for avoiding costly mistakes. Estimators should review their completed estimates for errors or omissions. Comparing figures with past projects or industry benchmarks can help identify potential discrepancies. Consulting with experienced electricians or engineers can also provide valuable insights. Staying updated on codes and standards is crucial for ensuring estimate compliance. Electrical codes and regulations change frequently, so estimators must stay informed of the latest requirements. Attending industry training and seminars can help estimators stay abreast of changes. Documenting all assumptions is important for managing expectations and avoiding disputes. Estimators should clearly state any assumptions made during the estimating process, such as site conditions, access restrictions, or material availability. Transparency helps avoid misunderstandings and facilitates project communication. In conclusion, electrical estimating requires a meticulous approach, encompassing material costs, labor expenses, project overhead, and profit margin. Utilizing specialized software, verifying estimate accuracy, and staying updated on codes and standards are essential for success. By following these tips, electrical contractors and engineers can create reliable estimates that contribute to project profitability.